the circuit, the properties on the graph, if I have to plot it from time 0 up to time infinite, if you say, it will start from maximum because it's fully charged, right? So maximum is when V is V0. So this axis is V, but this position where it's going to start is going to be V0. Why? Because time, when time is 0, that index is going to be 0. E to the power of 0 is 1. 1 times V0 is V0. So at time 0, is this whole thing is just going to equal to 1. Okay, so that's why it's V0. Then it's going to decay exponentially, like so. And then it reaches a line, like it's going to eventually meet 0. And that line, where it's going to go towards to, is called a asymptote. Asymptote. It's a line where the graph is going to tend towards. Okay? So, here's the big question last lesson. What would the charging of a capacitor characteristics looks like? Well, I didn't draw it, but your head should be thinking it's got to be the opposite. Okay? So the question is, what do I do to these equations to make this just flip upside down? Obviously, at the time 0, the voltage of the capacitor should be 0. It should be completely discharged. So when whatever happens, t when it's 0, this equation must turn into 0, so that V is equal to 0. So how could I do that? Well, I'll let you finish writing down first. So because this part, if you understand it, it's like you feel good about yourself. If you don't understand it, doesn't matter. It is just another topic that might take it a little bit longer. No, I'll show you. It's really simple. It's just about adding and subtracting. Okay. So this was my, well, when I was an A-level physics student, this was a homework task that the teacher won't tell us the answer unless we figure this out ourselves. So it could take months, it could take weeks. So one has to figure this out. Okay. So I think it took me about 3 weeks to figure out. And then when I figured out, actually, I thought this is like a 5-second job. Okay. So now let's remind ourselves. So if everyone looked here, okay, please. So when t is 0, for this equation, it will be V equal to V0. So to make that to be 0, all I need to get is an equation so that I can have V equal to V0 minus that. Because if you think about it, if t is 0, this is just V0, right? To make that 0, if I do V0 minus that, it will give me 0. Now that's just how I thought of it, just to get that 0 position. And then I realized it worked all throughout. If I put this now into Desmos.com, it will work. It will be a complete opposite, which is what I'm going to demonstrate now. So if I get back to the Desmos.com, okay. So obviously I need to put some numbers in. So let's do the first charging formula. So they don't like me to use V, so I'm going to have to use Y. So Y is equal to, let's say the battery is 5 volt. Okay, so it's going to charge to maximum 5 volt exponential of minus negative x, because they don't like the t either. So divide by RC. Let's just say it's 10. Just get no, that will take a while to discharge. So let's go for 2, maybe a nicer one. Okay. So I copy this. All I'm doing is just put V naught, which is 5, minus this equation. So yeah, V naught, which is 5, minus itself. Look, opposite. Okay, complete flip. Okay, and that's the charging. Okay, now, but guess what? If you are mathematicians, GCSE level, what can you do to simplify this? They both have a common factor, V naught. So what do we do? Take it out, put it, so factorize. So basically, the charging formula is V equal to, take the both V naught out of the bracket. So V naught times what give you V naught? 1 minus V naught times E minus T over RC. And that's the equation you see constantly in the textbook. But I like this version because this is the key to unlock how we get from there to there. Okay? Alright, so it's recorded. So if you need to watch the video again, okay? So, alright, so that's that. So just to summarize then, so we have one is V equal to V naught E minus T over RC, and then the other one is V equal to V naught bracket, just add 1 minus. Okay, so if you're going to do A-level physics, or you're doing A-level physics, most people memorize it, but the safest way is to do that. I don't remember if they give you the formula, but definitely in engineering they give you this formula. Okay, I think, but I'll issue you a formula sheets as we get go along this, so you always have the formula in front of you, so you know what formula needs to memorize and what you don't. Okay, so discharging, charging. So the way to remember, I don't know how you can remember. I always think of minus. Yeah, that's not really a good way, because most people think minus is like getting lower, so they think it's discharging, but it's actually the opposite. So, so I don't know how you could remember that. Okay, so I don't remember this. I just do this and then derive it myself, or every single time. Okay, so that's that. Okay, so now we're gonna try a real problem. What are you looking for, James? Yeah, just behind the photo frame. Okay. Okay, so what I want to do now is just cut out a question so then we can explore together. So is this one here? It doesn't let me, does it? So we have to do that again. Snip and sketch. Okay, so we go like that. Okay, zoom in. Okay, we're just about able to see that, can't we? Can you see the words? So is that's dongle, isn't it? Oh. Mind the cable. Lovely, sir. Thank you very much. Now, I'll ask you to look at this question just to digest all the key information. So have a look at this first. Okay. Okay. So it might. Hopefully, it works. Yeah. Well, first of all, what are we trying to calculate? Exactly. So we know we need to count the V. So which is this V? Okay. All right. So microfarad. Okay. Well, that basically brings me to what you know already. Now, I don't know if GCSE you learn about kilo, pico, tera. Yeah. Yes. Of course. Yes. Yes. Um, you got to, do you do physics A level? Okay. All right. Because there's different. If you do physics, you might not like what I'm about to show you, um, because I'm just trying to get everyone to understand. Okay, so first of all, there's the small, and then there's the large part you need to remember. So you've got kilo, okay, and that's 10 to the power of 3. And then what's the next one up? Because we only like to deal with units that are in orders of 3. So the next one is going to be 10 to the power of 6. What would that be called? Mega. Giga. Tera. Okay, that would do. So giga and tera. That is enough for the whole of the engineering course, I reckon. And then the small one, equally, we go -3, which is milli. Yeah. And then micro. And then -9. You heard about nano? Yeah, nanotechnology. 9 is that's the best one to remember. N9 nano. Next one, pico. That's it. Okay, so we often with capacitance we have capacitance between nano and pico. Quite a lot of pico actually. So because even with keyboards, you need a capacitance capacitor to work, and the capacitance of touching is so tiny. So is all it requires for a digital electronic to work is that small amount of capacitance. So yeah, so pico is quite common in capacitance. Okay, otherwise it's very rare we talk about pico in other cases. Even bacteria, we are talking about micro only. So yeah. All right. Okay, so going back to the problem then. Right, year 13, come on, you need to be quiet in here, okay? Thank you. So, where is it? Okay. So what do I know? Do I know V naught? What is it given to me? Yep, it's given to me V. So what I would do in the exam is that I will take. So does it work? Yeah. Okay. So so I know V naught. Do I know T? Yes, I know T. Do I know R and C? Yep. So now we know 10K is 10 times 10 to the power 3, or you can do 10,000 if you like. And then 100 is 100 times 10 to the power -6. Okay. So yeah, plug that in and see what you get. What I'm gonna do. Anyone not got a calculator? Okay. So help yourself between the is next to the hi-fi. There's a stack of calculator. Yeah. Who's A level physics in here? Okay. so yes, so convert. So everything should be on in SI units. So it will be in farad. So don't put 100 in there. Now those who are physicists, what you will have to do in exam is to know that micro and kilo, they will cancel out by a factor of power 3. So therefore, that's -6, and that's 10 to the power 3. So when you times them, it times 10 to the power of -3, basically. So you have to do that in your head quite quickly. And they give you numbers so that it's nice to work with, okay? Whereas us, we probably just put 10 to the power -6, 10 to the power 3. You've got to be very good at just, I'm sure some of you will spot that yourself anyway. But if you're not confident, then you will plug everything in, 10 to the power 3. But it's just a bit quicker without having to type 10 to the power 3 in your calculator. And how would you type that in your calculator? What button would you use to put 10 to the power 3? I use this one here. Okay, so let's say R is 10, yeah? I go that button at the bottom and then 3. Okay, I still see some year 11 students or year 12, they would use this power button. So you go 10 times 10 to the power of 3. Okay, but the 10 power 3 button is already made for you here. So do use that. Some of you use a more professional calculator, would be EXP, okay, which is an exponent, okay, but to the base 10. So there we are. So let's do that then. So we have, this is a charging, so I need to use the charging function. So V naught is 3, bracket 1 minus, and then E to the power of, so fraction, minus 3 second all over 10, because it's kilo and it's micro, so I'm just going to use 100 times 10 to the power -3. Okay, it might be quicker, and then close the bracket. Did I not open bracket? Oh, yeah, I did. No. Oh no, you don't. The fraction doesn't matter because it's already been raised to the power. So yeah, it should. Oh. Okay. No, it's the entire equations, but they don't like it. Yeah. So that's strange. Let me just try this again. I want to see where. I know. Let's do that. That should give me 27. Yep. So I don't need the time sign. So what did I do? Unless they really want me to put a bracket on the index, which is, yeah. What's so you have a look. Maybe you can spot I make a mistake or something like that. So I then put. Yeah, but I done the times to 10 to the power 3, 10 to the power -6, which equates to -3. So I save me from typing extra things. That's all. So therefore it should be a fraction, and then I put the minus at the top, and then I'll see 10 times 100 to the power of -3. Okay, here, yeah, the denominator. So let's try that then. Like that, yeah. Okay. Let's. Ooh, if I get this wrong, it will be another. It's gonna take ages then. Okay, there we are. Now. It couldn't possibly be. So you got a straight 3 as your answer. Now, if you think about this, you are charging. Yeah. So after 3 seconds, you unlikely to be reaching the maximum yet. So I say close to 3 is good, because to get exact 3 you need to go infinite when time t is infinite. So that's why what I was about to tell you all is that whenever you get an answer, interpret it like an engineer. You are charging, so your answer should be less than 3. So therefore 2.85 sounds good. Okay, so has anyone got 3 as well? No. Have you still got it on a calculator? Yeah, that's alright. No, it's okay. And then round that to 3 significant figure, so 2.85 volt. Okay, and then put a bracket next to it and say 3s.f. You got to show the examiner that you're rounding. Okay, is that clear? Okay. Any questions on this? So this is a typical exam questions. And then the next example, don't know why it's not. Maybe I can zoom in that way. That's perfect. Okay, so the answer is 2.85 volt, 3 significant figure. Okay, so there we are. Okay, so if can anyone see this from where you are? So do I need to cut it out? Okay, that's no problem. So I will do that. So well, we might shift Tom, because what I like to do is next week we do a rotation. So if you sit here, you sit one back, and then if you're there, you move there, and then you get a rotation around every week. So you have in a different angle. Okay, so let's. If you can see it, then can you calculate what time t equal to? So slip sketch again, and then bring that. Right, that's not good. Doesn't like it. Okay, let's just put it here. Okay. Zoom in. Okay, there we are. How do you find t? What I would suggest you do is, before you find t, rearrange the formula so that t is the subject of the formula. Can you do that? What's the opposite of E? Thank you. Yes. Check the calculator. Where's the E position? The opposite is likely on the button. Yeah, it says ln, doesn't it? Yes. I won't know because it's French calculator, isn't it? Yeah. Okay, what did you do first step to rearrange? Prades? What is it? What did you do to rearrange to make t the subject? Which term are you getting rid of? You don't want the V naught, you don't want the RC. Which one do you get rid of first? E? Okay. You can. It will complicate things because you got ln V naught. I would divide by V naught first. Did anyone divide by V naught first? Okay, so okay, so I'm going to divide by V naught this side. I'm going to divide by V naught this side. So V naught and V naught cancel out. So V over V naught is equal to E minus T over RC. I wouldn't lend for straight away because I'm a little bit worried here. Is because I got a negative index. So, but then if I lend that would get rid of that, wouldn't it? So I suppose it's all right. It should be all right. Let's see if it works. If it doesn't, we just start again from this step. So if we take ln both sides, so we need to ln both sides. So so E and ln cancel out, so therefore it just leaves us with minus T over RC. Yeah? And then now we can get rid of the RC term. We can treat RC as one thing, one single letter. So if I divide by RC, the opposite would be times both sides by RC. So I times this side by RC, I must times this side by RC. So therefore RC ln V over V naught is equal to minus T. So in other words, I can throw the minus to the other side. So T is equal to negative RC ln V over V naught. Finished. Okay, as I said, when you get an answer, I would always double check if it's sensible. The first thing I see is a negative value. Can time be negative? No. But guess what? This is just telling you this whole formula is going to be negative. That means somewhere along the line, there must be a term that will be negative that makes negative to turn plus. Can't be RC. R and C is a positive value. So whatever happened after you do the ln of V over V naught, it should give you a negative answer. In order to turn the minus makes a positive. Okay? So go ahead and do that for me. Ln V over V naught, does it give you a negative value? So now we substitute. So what we will have is minus 30k times capacitance 10 times minus 6, and then ln V, which is the 3.5, over 4. Does this term gives you a negative value on the calculator? It does. Yeah. So if it doesn't, then that's worrying. Then this formula, I would go back and check that out. Okay. So if it does, what's the final answer to the time t equal to then? Okay, so you got 0.18. Okay, is it if let's go for 3 decimal place then? What would is not? Oh, all right. Who's got an answer then? You can type all of that in one go, I reckon. But normally I would type that in a calculator for the final term first, and then put that in. So not everyone's typing on the calculator. Okay. So anyone got an answer? Anyone wants to confirm that's the case? Is 0.188? Okay. So again, I put a bracket to say that it's 3 significant figure. Okay, so 0.118 second. Just check with the textbook. This is the case. So I go back here. Yep, 0.188 seconds over here. Okay, that's it. All right. Any questions before I move on? Just want to quickly introduce different type of equations on here, and then possibly we'll continue next lesson. Okay, so yeah, so couple of points to remember. Make sure you round to either 3 decimal places or 3 significant figure will be good, and that you recognize which equations is charging and discharging, because that allows you to interpret your answers rather you are doing it right or wrong. Okay, what I would say is this example is a bit easier because they don't normally tell you given by the equations. They will just tell you to work this out, and then you have to recognize that it's about its charging. So there should be a term. Look, you see, discharge. So immediately I will look for the discharging equations. Okay. So, okay. What I would like you to do is do a new title. And your new title is linear equations bracket straight line graphs. Okay, linear equations bracket straight line graphs. So I'll do that now. Let's see, linear equations bracket straight line graphs. So for some reason it's going a step back. They started exponential graph, now they want us to go back to straight line graphs. Okay, that's because in the first engineering unit coming up in the unit 1 is on forces, and forces are linear. Okay, so what I would like you to do, again I will zoom in, so snip and sketch, hopefully. Okay. This is yeah, you cut out all the, well, you don't have to learn about leptons. Okay, that's pleasing. Quarks, you know, that for me is really good. But yeah, how many percentage of matter that we know now as human being? Yeah, matter. Just, I mean, simply looking at the periodic table on the wall there, what percentage of that do you think we know? Yeah, you're not bad. Yeah, it's yes. The rest of the matters are called dark matter. Okay. Yeah, so dark matter, is still in that same group. Yeah, but there are matters that we can calculate as a mass, but we can't get hold of it. We can't spot where the mass come from. It's invisible, so that's why they're considered as dark matters. Yes, yeah. Well, right now we are breathing in dark matters, possibly, but we don't know what they are. Yes, and that's what you know. If you're doing physics, and those who might go to Durham University, yeah, that's your whole lifetime as a physicist. is to continue identify new matters, because those new matters, those dark matters, that if you identify them, that they could be the one that the sort of things that we're looking for, energy, you know. So yeah, okay. So before you write, copy this down, because these are quite important common formula. It's just that I want you to spot why they are called linear. Okay, so let's pick the first one here. Let's go for this one here. Okay, so let's say V is equal to 5 lots of resistance, where 5 is the current I. This is the Ohm's law, yeah. So if I put V R here, V here. So for if R is 1 times 5 is 5. If R is 2 times 5 is 10. R is 3 times 5 is 15. I think that's about enough for me to demonstrate linear. As you are going up 1, what happened to your output variable is that it's going up by the same amount each time of 5, and that's linear. Okay, if you go up 1 every time, and on here it's go up 5 then go up 6, that is not linear. Okay, so in other words, you call that non-linear. So today, we're dealing with, in these sessions, we're dealing with linear. Okay, what is non-linear? Exponential, we just dealt with, is non-linear. Okay, so if you look at all of this form equation and do exactly the same thing and do a table, you'll find every time you go up 1, whatever the variable output is, it will go up the same amount. And I guarantee you they are the case, and that's why these are all linear equations. Okay, so just can you draw this table in your exercise book, please? Okay. Instead of going through every one of them, can you tell me which one you haven't seen before? Which formula here you haven't seen before? Yes. Okay, resistivity. Okay, fine. Really? Okay. That is very interesting. Yeah, well, why could mx plus c? Oh, okay, so it's not all of them. Okay, all right. Well, that scares me a lot. Well, even Ohm's law, you haven't done Ohm's law. Okay. Well, first of all, welcome to England. But I love France. So I wouldn't destroy their educational system. Although in France, mathematics, GCSE, they have to learn to program as well as part of their maths. Well, don't you? I tutor French mathematicians. Their syllabus, you have to write. Yeah. So, oh. Oh, unless were you doing the British you were in France but doing the British GCSE? Oh, whoa. Okay. Yeah. Well, it was part of the maths. You have to write either Scratch or Python code along with, say, yes, yeah. Yes. Yeah, I like that. You know, that's exciting. And I mean, I wouldn't want to teach that in England. Yeah. Anyway, I will explain. No worries, it's no problem. But those people who think they know everything about Ohm's law, I'm gonna give you a bit more excitement there. Have you heard of superconductor? Okay. And Ohm's law here, the formula is a mistake, by the way. Okay, keep copying it. Yeah, keep copying it. Yeah. If if I did this once in an interview, so it was a gentleman. He's done 10 years already of engineering, and all I asked him was, what's Ohm's law? And then he said either V equal to IR or I equal to V over R. That's not Ohm's law. That's a formula. Okay. Ohm's law is the increase in voltage. Okay, it should give you increase in resistance. Okay, that's definition of Ohm's law. And because they are proportional, so hence V must equal to IR, and I is the factor of the increase. So Ohm's law is a law. This is a formula that relates to voltage, current, and resistance. So yeah, this is bad. This is bad. This is teaching lots of people who can't be an Einstein because of this simple things. You don't ever do that. Okay. But we use formula to solve voltage, current, and resistance. Okay. Okay. So Ohms. So is a guy. I don't know if he was French at all. I don't really look at the history, but definitely I don't think he was British. So he basically found these properties. If you increase a current, you get an increase in voltage, and just that simple is what he found. Okay, so imagine us doing that every day now. Okay, so that's that. So he just calls that there's a behavior between resistance, voltage, and current. Now what I would like to do is I want to jump straight to the resistivity. Okay. Now, if I give you a battery, okay, let's draw a battery like a real battery, positive here, minus here, okay, and I said to you, if I put a wire through, this will catch fire, okay, because that acts as a light bulb. Let's say it doesn't catch fire, so the current moved from positive to negative. Did you know that? That's called a conventional current. You don't have to accept that. That's upon 60 years ago, we decided that, let's say, current moved from positive to negative. Okay? But there's no such thing as current, by the way. What's actually doing is those tiny little electrons, yeah, with a charge of 1.6 times 10 to the power minus 9 coulomb, they are moving from negative to positive. They're doing work, they're moving. So therefore, it's not very good to teach students saying electrons are moving. Yeah, it's best to say current. So that's why we decided that currents, if electron move, there's a current. Okay, this is just invented. So if this current from the battery is 5 amp, then most people thinks the current on here is 5 amp because there's no resistance, right? Okay, but there is. A wire has resistance. Look at the light bulb. The filament is very thin. So this is the wire, and this is the wire in the filament. Okay, I'm just trying to exaggerate the difference. Okay, so resistivity is to measure how much resistance there are for a simple piece of metal, maybe a cylindrical version, and that's the area. Why do you in GCSE need to learn the cross-sectional area? That's because we need it to work out in electronics the cross-sectional area. So the cross-sectional area is circle. What's the formula for circle area? A equal to. Have you done the song? Have you done the song? Circle song. Circle song. When I needed. Yeah. pi r squared sounds like area to me when I need the circumference, when I need pi d. Yeah, have you done that one? Okay, so pi r squared sounds like area to me. So pi r squared is the area of circle. So if I know, so the bigger the area, because it's in the numerator, the answer to the resistivity will be proportional, will increase. So the more of this cylinder, the bigger the chunk, the thickness of the wire, you get more resistance, basically. So to make a light bulb really burn, you want that to be as low resistance as possible. Okay, so therefore that's why the A must drop in order to get the lowest resistivity. Okay, and so therefore that's this formula to work out the resistance of the wire. Yes. Now this is the major hazard you're going to be doing. You go, you know, this AC adapter, 230 volt out. Why do I need this thickness of the cable? It's because of this resistivity. Because the higher the current, so let's just write that down again. So rope, this is called rope. This is a Greek letter, simple rope, and is equal to RA over I. Now I know what's coming out here needs to be 13 amp. So I know this is 13 amp. Okay. The question is, and I know I need the resistance to be as low as possible. Let's say 1 ohm. So what do I need to create? What wire do I need to get a 13 amp? And that's what you need to work out by rearranging the formula. You need to work out what A is, and that's why we choose the thickness of the cable. So basically, the higher voltage you need that you use, you must use a thicker wire. Otherwise, it will just disintegrate. Okay, so that's what it is. All right. Until next lesson. So thank you. There will be a homework task for you to do. I'll send you the detail. It's on Unit 1. Okay.